This is a device that produces the same sort of rat measurements as the game Ship Odyssey. I'm going to run it, adding rat readings to this graph slowly. When you think you have enough information, call out the location of the treasure. If your prediction is within plus or minus 2 of the actual treasure location, you win. Here we go. This blue triangle shows the location of the mean. Okay, somebody has probably made a guess by now. I'll open this up, and you can see that the actual treasure location was set at 33. So if your guess was between 31 and 35, you would have captured the treasure. Let's continue and draw a total of 100 rat measurements. After 100 samples, the mean is very close to the actual location of 33. This red line is the median of the data. It too is very close to 33. Let's explore what happens to the mean as we grow a sample from size 1 or 2, where we know the mean is not a very reliable estimate, to 100, where we know it is extremely reliable. Let's do that again. Watch carefully how the mean moves as the sample gets larger. Pause the movie and describe what you observe about the movement of the mean. What we observe is that when the sample is small, the mean moves around quite a bit as new values are added. But as we add more and more data, the mean moves less and less. As a random sample gets larger, the mean of the sample stabilizes or settles down. Imagine that the mean was a pen and left a mark as it moved around. Here's another graph of the data that basically does that. The red line shows the actual location of the treasure. This gray line is a record of where the mean has been as the sample gets larger and larger. Let's draw some samples and watch this graph. Again, we observe that when the sample is small, we see a lot of movement in the mean. But the movement becomes less and less as we continue to add data. And note where the line or the mean settles down at, very near the true location of 33. Instead of using the mean of our data, we could use the median instead. This red line is the median, and it behaves the same way as the mean, stabilizing as the sample gets larger. Okay, think about how you can use this understanding to improve your play in Ship Odyssey.